Hello. So we're going to try to solve a problem called the 0, 1 matrix, and the problem is shown right here. The problem description is: given a matrix consisting of zeros and ones, find the distance of the nearest zero for each cell. The distance between two adjacent cells is 1. And here's an example. You can see a 3x3 matrix, and it has 1, 0, and you have to find the distance to so the output is shown right below, and the distance to the 1 is 0 for each case because they all touch. Now here's another input. It's 0, 0, 0, and then 0, 1, 0, and then 1, 1, 1. So we're trying to find the distance to the zeros, and you'll see that's the given in the problem here. The distance between adjacent cells is 1, and the distance to the nearest 0. So in this case, the output is shown below, and it has a 2 here because the 2 is, if you count 1, 2, it's always 2 from a 0, right? So it gives other criteria, like the number of elements in the matrix will not exceed 10,000, and there will always be at least 1 0. And the cells are adjacent only in the 4 directions: up, down, left, and right. That makes sense. These are all important questions that you should ask. Are they adjacent on the diagonal? That would change the problem. Now, let's say you have a 100 by 100 matrix, and one simple way to solve this problem is to use brute force. You just keep track of where all the zeros are, and then for every one, you simply calculate the distance to all the zeros, and that would be n squared, because you're doing a breadth-first search across the entire matrix. Of course, for every xy, you have to find the distance to every other zero, which could be every single cell in the matrix. So think about that solution. If it's 100 by 100, you'll find that the number of operations would be 100 with 10 to the 2 times 10 to the 2, which is 10 to the 4th, but then there could be 10 to the 4th zeros in the problem too, so then it's 10 to the 8th, which is a big difference. 10 to the 4th jumping to 10 to the 8th, that would slow down a computer. It even slows down this leak code thing, and it just says time exceeded. So we use dynamic programming, and dynamic programming helps us by making 2 passes through the matrix, right? You first make a forward pass and then a backward pass, and that can solve the problem if you do it right. Now, we have a visualization that will show the forward pass. You look left and up, and you leave a trail, and on the backward pass, you start at the bottom right, and you look down and right, and you leave a trail. And so that's how we solve it. Now, let's try to visualize. Good. Done. So we will do this in the second half.